So back, for example, for everyone, I did have to take a moment to think through this in a little bit. There is a typo in this presentation here. There should be another caret, one of these things right here after the 0.5. And so I will correct that in the thing that you're going to receive right now. What you will see when you get on is that. Then this will work correctly. I obviously am not going to change it just for the purposes of mine because I've already done that. So I'm going to jump straight to number 3. We're going to graph this curve in GeoGebra, and it's interesting that this one behaves the way that it does. So we've got a hospital administrator that predicts that the growth in the number of hospital employees for a new hospital will follow this equation. And you can see that at 0 here, this hospital started with just over 1,000 employees. It looks like 1,000 is right here in the middle. They probably started with about 1,250. And the population of workers in the hospital is growing over time, but it's eventually going to top out and they won't need more employees. Obviously, a hospital is only so big. And so it's going to reach what we call global maximum, that it will never get above that number. And that's why this curve has a tendency to flatten out right here at 2,000. So the number of employees when the hospital first opened, I would guess, based on my graph here in GeoGebra, that it's about 1,250. 1,200 is what GeoGebra is saying. We can use Wolfram to validate that. And then after 1 year, it looks like this grew to be about 1,560. Again, we will check that with Wolfram. But we can see from this graph that the number of hospital employees will never go beyond 2,000. It will approach 2,000. And it's interesting the way that this works. If we go way out here, if you're a person that's taken calculus, this will make sense. But this should be at the place where it never reaches 2,000. It will approach 2,000, but it will never actually come in contact with it. It is saying that it's 2,000 way out here at 80 years later, but I bet that that's a rounding thing, and then it's really more like 199,000.999 or 1,999.999999999. At any rate, we are going to go ahead and throw this in Wolfram and see how close our sort of guesses using GeoGebra here were. So again, my guess is when it first opened, it was 1,200 people. A year later, 1,560. And then for part C, it is going to be that it's never going to exceed 2,000 people. So let's jump right in with Wolfram on this. I'll bring my iPad up and get the math written down that we need to be doing. So we would have N for the number of employees is equal to 2,000 times 0.6 to the power of 0.5 to the power of t. And it's kind of strange to have an exponential function inside of an exponential function like we do. But that's how we're rolling today. Something a little bit strange for us. And so in the case of when the hospital first opens, everyone, we are going to have an instance where time is equal to 0. So we will have 0.5 to the power of 0 is what we're going to be putting into Wolfram for this one. I'm going to copy from the presentation, and I will have to fix it because, as I demonstrated earlier, I do have a typo on this one. Yours will not need to be fixed. You do not have a typo, as I have already taken care of that. So my typo was right there, and I need to replace t with 0. So I do get the same thing I did when I sort of guesstimated from GeoGebra, 1,200. So in the first year of operation, the hospital will employ 1,200 people. In the beginning, the hospital will employ 1,200 people. Secondly, we are asked how many employees the hospital will have after 1 year of operation. So all we need to do is take this t, which we had set to 0, and put a 1 in there. And we get 1,549 employees. So we are not going to round up in this instance. It's impossible to have a partial employee. So we have 1,549 people will work at the hospital after A better way to say that would have been, it's predicted that 1,549 people will work at the hospital after 1 year. We really have no way of knowing that or proving that that's going to happen, but it is predicted that many people will work at the hospital after 1 year. And then, as we saw from the graph in GeoGebra, I can bring that up as well. The graph approaches but never goes past 2,000. And so the maximum number of employees we can ever expect to be working at this hospital is 2,000. So again, the max number of employees we can expect to be working at the hospital is 2,000. So with that, that's going to be it for the examples. We're going to be on to the problem set. We're going to knock this homework out, and we'll be on to lessons that will teach you how to become richer than your wildest dreams.